Continue with the earlier technical training on HSG advanced features. Last time we talked about, since the start of the HSG focus training, we talked about some of the HotSpot gateway configuration, and the videos are there, and we talk about the basic steps to deploy MAP. And we also talk about getting some access control for HotSpot users using different ways. Then last week we talked about the advanced feature on client sticky and some of the bypass features. So this week we're going to focus on the dynamic bandwidth control, and we're going to use the same lab topology, which is basically having a MAP connect to the HSG, and my PC is sitting here. So I have done. You can basically download the config from lab 2, but for this lab, because we're going to do a dynamic bandwidth control, so because we don't have a lot of live users, so I would basically restrict my upstream bandwidth. So what I've done here is I have enabled traffic shaping for my box here, so it's limited to 10 meg. This is this is 100 meg, and 10 meg here. So I will make the configuration change here. So what I'll do is there was a little bit configuration mistakes here. Just 10, okay. And here as well. The unit is in bit, so okay. So if you want to understand more about traffic shaping, how to limit network-based bandwidth, you can actually refer to the documentation guide. In here, for example, if you can just type shaping, you will redirect you to the necessary sections to explain what is a network and application-based traffic shaping, how do we limit upstream and downstream on a per network or per application basis. Or if you browse on the left side, it'll be under the bandwidth control. So today we're going to focus on the dynamic and adaptive QS. So it's basically, if you look at our earlier training, we restrict bandwidth based on, it can be using the command line, which is to set a cap of, let's say, 2 meg or 10 meg per user. Or you can set it on the radius profile or radius user access setting. So all those settings are static. So that means if you set 2 meg, it is fixed to 2 meg. If in a typical large network, for example, a shopping center or a hospital, when the backhaul is huge, let's say there's a 100 meg internet access circuit, and if there's only one user using it, and if you use static setting, you are still capped at 2 meg per user. So this is very inefficient use of the network resource. So the backhaul is not fully utilized, and the user can still complain slow because he's only getting 2 meg maximum. So what this dynamic and adaptive QS aims to do is to allow the provider to, or the venue owner to fully utilize the backhaul resource so that users can get maximum performance while still keeping the network congestion under control. So the dynamic bandwidth control management is basically by measuring the number of active users on the network. So let's say if you have one user on the network, you can actually allow the user to access burst up to 100 meg, but you can still set a cap. I allow you to burst, maybe burst to 10. And when there's 50 users, so each one was equally sliced down to be maximum of 2. And you can still set a minimum so that it could be 100. When you reach 100 users, you don't slice them down to 1 meg, because not all users will be fully utilizing their given speed. So you can still set a minimum and maximum. So a maximum, basically, when they are bursting, they can burst to a maximum speed. Minimum is when you are slicing them down per user bandwidth. When you slice down, you don't slice down to the extreme low, because again, not all users will be fully utilizing the network, will be fully utilizing the given speed. So the adaptive is a little bit more advanced, and we'll talk about that one later. So for now, we will try to demonstrate the dynamic one, which is basically very simply put it this way, is to slice the per user bandwidth based on the number of active users across the network. So, but of course, the active also has certain definition. It has to be user who have logged into the network, not the user who are associated to the network. Because in an open network, SSID environment, open Wi-Fi environment, there can be a lot of users associated to the Wi-Fi, but they don't really use the network. So we don't count them as active user. Otherwise, the amount of active user would be too big, and this is meaningless to do dynamic bandwidth control, because everybody will be just getting the minimum speed anyway. So the dynamic control is really to allow user to burst when the network is usage is relatively low. But if the network is always high usage and busy, and you probably don't see much benefit of this. Okay, so I have this similar setup from the previous one, and we have this HSG and we have the MAP. Then I have my PC connect to this port to manage the HSG. And because my office network is a 100 meg link, so I have purposely done a shaping to slice it down to 10 meg. And if you re-look at the whole configuration, the shaping is applied to the outbound, which is for the upload, and the inbound. The inbound, when it is running HotSpot on the interface, you will apply within the HotSpot instance rather than on the physical or the logical interface. If it is just a normal internet access, direct internet access without any HotSpot service, you will apply the command under the physical or VLAN interface. So it's just like, again, you can refer to more details in this section. So I have configured connect my PC to the HSG UI, and I have the MACC, because it's a fresh box, which is just got it from the store. So I haven't added the AP yet, so I'm going to add in the AP. Just putting this AP serial number, and the AP serial number, I'm just going to have to get my AP serial number is just going to get my AP info, so because I don't have that serial number with me. Usually it's on the sticker because this is a demo unit. It's not on the AP serial number is here. And I'm going to apply template to this AP. And on this template, I have configured two SSID. One is VLAN 10, and which is mapped to VLAN 10. Okay, it's the SSID VLAN 10, SSID VLAN 20. We can go into that template config for more details later, just for the benefit of some of us who didn't attend the earlier session. So you can look at the template config details. So SSID 10 is applied to VLAN 10. So you can check the VLAN SSID config details. So we just wait, I just apply the template. So we wait for the config to be fully synced. So far it's not synced yet. So look at the log status, it's still in progress. And you can, if you can't wait, you can just look at the progress details. And this SSID config has been just applied. So I'm just going to look at my phone to see whether the SSID is already there. Okay, so the SSID is there, so I will come back later. Just make sure the whole config is being pushed down before you do any testing. Okay, so it's fully synced. And on the mbox, I have VLAN 10 and 20 configured, so it's mapped to the AP's VLAN 10 and 20. So I have also on the CMS, I have also configured a portal called VLAN 10 to which is require the user to log in using Facebook, and the URL is being applied to VLAN 10 instance. So although I have VLAN 20 here, but I'm not using it for now. So I just show security hotspot status. So I already have two users logged into this VLAN. These are basically my colleagues who are assisting us to do the testing. So if I look at the Reddit's online status, they are here. Okay, so that's Joseph and Ryan. So next time you'll be calling them for support. And the user profiles are grabbed down here as well. And so I'm going to log in with my Facebook account as well. Okay, because I have already logged in before, so what I'm going to do is I'm going to clear my browser cache just to simulate a more realistic scenario. I have this resonance stand. Just going to put it here. Okay, so I'm going to connect to VLAN 10. Nice. So I'm going to choose log in with Facebook. So I'm going to just have to take away to key my password. Okay, putting my passwords. I'm just going to log in. And so I'm done. I've logged in already. So if you look at the online user status, so that's me. I have another colleague also logged in as well. So there are basically 4 of us. And if you look at the clients, there are 4. So these are the 4 ones that are active. You see there's a percentage sign under this status for each of the columns. That means the users are active. Okay. So I'm going to do a speed test first before we proceed further. Okay, so I have limited my mbox HSG to 10 meg, as we explained earlier. So this is the total amount of capacity that I'm enjoying without any control, because that's what is available on the network. So what I'm going to do is now I'm going to enable dynamic bandwidth control. And so we have, if I'm non-controlled, I'm getting the full maximum 10 meg here. So I'm going to control this now, because if you see it's non-controlled, basically it shows 0 under the max up and max down. So I'm going to control under VLAN. So I'm going to enable dynamic bandwidth control. I've already have the command here, so I don't have to key here. Okay. And so basically, it tracks the active number of users every 1 minute. So what I just want to go through some of the syntax options. If you key in dynamic, you can either choose adaptive or dynamic, or if you just key in the actual number, it will be the fixed cap. So if you put in dynamic, it's basically auto-adjusting based on the number of active users. So let's say I use dynamic. So this is basically the upload and download total speed of the backhaul. So you can set minimum and maximum. So this basically is what this means. Makes maximum per user. Even if there's a 100 meg link, and even if there's only 1 user, you don't want them to burst to 100 meg, because that can be a security concern. They can use your network to do a DDoS attack to somebody who has lower speed, backhaul speed, and then they're basically abusing your network. So straight away, as you can see, I'm slicing the available bandwidth between the 4 users. So each one gets about 2.5 meg. So that's basically how it works based on the number of active users. So I'm going to do a speed test again. So immediately I'm sliced down to 2.5 meg. That's really close to 2.5 meg. It's not 100%, but it's somewhere there. So this is basically how it works. So what I'm going to do next is I will probably kick out one of them, so that we know this user, like I say, is not active user. As you can see, the status doesn't have a percentage sign. So there's really only 4 active user. So if you just look at the online user here, 1, 2, 3, 4. So there's really just 4. So what I'm going to do is I will kick out one of them, so that it leaves us to 3 active user. So slowly, it should just increase my cap to equally slice the available bandwidth again. So if you do this, it takes about probably it's around 1 minute to reflect the change. Okay, so I'm getting 1/3 of the available backhaul, because there's only 3 active users. So I'm going to do a speed test again. 3, it just increased from 2.5 to 3. So as you can see, it's fairly accurate and it works exactly to what we want it to behave. Okay, that's basically how dynamic bandwidth control works. Again, allocates per user speed based on the active number of users. So the next we're going to talk about is the adaptive QoS. Adaptive QoS works slightly, or rather is a more advanced way of controlling the user bandwidth, because the dynamic control based on the number of active users. So for example, we allocate 3 MAC per user when the backhaul is 10 and we have 3 active users. So we give them 3. But really, among the 3 users, not all of them will fully utilize the 3 MAC. So let's say if one of the user needs 5 MAC, another 2 really just need 1 or 2, but I'm giving you 3. But the one who needs 5 MAC are still giving 3 only. So like, for example, myself, I'm still giving 3 MAC only. So I'm unable to fully utilize the available bandwidth, available bandwidth who are not being used by others, which are not being used by others. So the adaptive way of controlling is to track the actual usage of the backhaul. So it doesn't matter how many active users you have. Put it in a very blunt way, it doesn't matter how many active users you have, as long as the backhaul is not congested, I want to allow the user to burst as much as they can. But of course, you will still want to set a maximum and minimum. But within this range, they can burst as much as they want, as long as the backhaul is not congested. Okay. But if the backhaul is congested, I will start to suppress their burst until they reach to their minimum. So that's basically is more direct, is a more effective way of fully utilizing the backhauls capacity and maximize the per user experience. So I'm gonna do a demo, configure this again, and so I'm going to change that config. So what I'll do is I will remove that whole config so we can have a clean start. I still need to have this shaping so that we can keep the total backhaul to 10 MAC for this instance. So now instead of client bandwidth, instead of dynamic, I use adaptive, and I don't want to key in the whole command because I'm lazy. So I would just okay, maybe just want to explain a bit. So this is the total available backhaul, and if you look at the next option is the frequency of tracking the per user bandwidth, and it's also tracking the backhaul usage. So what I would do is I'll just set it to be 1 minute. You can set it to be whichever interval that you prefer. So if it's a relatively static environment, that means the users don't come and go very quick. For example, a classroom, you can make this to be a fairly big interval because the environment doesn't change so fast. But if it's a shopping mall or a train station, you want this to be short so that the changes can be reflected immediately. So I have just enabled the active. I'm going to put in the rest of the command. The portal and the bypass domain. The bypass domain is ready for me to log in using Facebook. So there's no one connecting now. Check my radius. Okay, so I'm going to get my colleague to log in again, and then we will start to test. So this time it's not so easy to measure because we don't need to count the number of active users. Instead, I'm going to ask them to do huge downloads so that it causes congestion to the network, or when the backhaul reaches to the 90% of the backhaul utilization, you will start to suppress down. If you keep on getting congested, if the congestion keeps on remaining, you continue to suppress until it's non-congested. So that's basically there's some proprietary algorithm being used to make sure to auto adjust the bandwidth. So I have two of them logged in. I'm going to log in as well. Because I already put in my Facebook credential earlier, so it's been cached in the browser. So most likely you will not ask me to put in again. Okay, so I'm actually already logged in. If you look at the status, and if you look at the number of online users now, okay, there's 3 of them, and I'm going to check the. So they have already started their large download. So for example, like this user, he's giving 5 meg. He used 80% of his download capacity. So that's 34 meg. So it's a little bit, like I say, it's a little bit harder to track this because the depends on how the individual uses their the bandwidth. Okay, so it's getting. If you look at the utilization of the WAN interface, I'm getting almost 10 meg. So that means I'm already getting very congested with the network. So the guys are really simulating very large download. So the throttling now starts. So instead of 5 meg per user, it doesn't drop tremendously. It just gradually drop. If the congestion continues, for example, if you look at the utilization, it's still 10 meg, you continue to drop by another 10%, or 20%, or 30%, until you reach non-congestion status, and you will remain there. And if the network is less congested, then the user will start to the assignment will start to slowly adjust back again. So it's very adaptive based on the actual usage of the backhaul. Okay, so it changes almost every 1 minute. So so that it's not so drastic. It's not so. It doesn't impact the user, unnoticeable to the user. It doesn't impact the user operations. Okay, it starts drop more and further. So just now it's 10%. This time it's 20% because the network remains congested. So still more than 90% of the network. So you continue to drop further until you reach to a balanced or rather equilibrium point, and then we will start to slowly recover back again. Okay, so again, it basically changes every 1 minute. Congestion still remains 10 meg. So it drops further and further until, so until it reaches the minimum configured, or the minimum configured speed per user. So you will stop there because this is the point where the network, the dynamic control is not useful or that is not helpful anymore because the network is just simply too congested. So let's let it continue for one more round. Then we'll ask my colleague to release their download, and then we can see whether you start to recover back again. You start to, so it's dynamic, adaptively changes the pre-user speed. It drops further and further. Okay, probably next round you reach to the minimum. This is the allocated per user speed bandwidth. Okay. The network is not congested anymore, so I think the guys have released their large download. We will slowly see the speed start to recover back. It doesn't recover so quickly because you know, we don't want the change to be drastic. It has to be slowly and gradually, so it doesn't impact the network operations. This is the, now it's only very minimum, so we should see this recovering pretty quickly. So now, you know, just now was 2 MB per user, now start to recover back. It's more than the previous one. So if you just keep on waiting, so every 1 minute you will start to change and change and change until as long as the network remains non-congested, so everybody will start to enjoy you know, whatever they want. So basically that's how the adaptive bandwidth control is, by tracking the actual usage of the network and adaptively allocate per user bandwidth so that whoever needs to use the network, you can use as much as you want, as long as the network is not congested. But if the network is congested, we will have to suppress you. And I mean, that's the purpose of ensuring fair usage of the network. Okay, it's at recover mode. So we are not going to wait for the whole thing to continue. You can always use your demo box to play with it. So that will be pretty much for this session, and we are just right on time. I'll see you again next week on some live demo on how to use HSG, the CMS 2.0, which is the latest version all-in-one CMS that has all the features in one template, and you just simply configure and enable whatever you want for the login portal. And I will look forward to see you again next week. Thank you very much for watching today.